Good morning to IR Dr. David Chua and Dr. Muhammad Iskandar. I'm Bang Hongkon. Today, I'm going to present my project, which is optimization of indoor air quality for small commercial office building. Introduction. The Express Standard 62.1 stated that acceptable indoor air quality is mean a majority of people exposed to not show dissatisfaction and authority had determined the air in will not have non-contaminants and harmful concentration. In office building, is supposedly to provide a clean, cozy, and comfortable environment with good indoor air quality to ensure the employee health condition, either physically or psychologically, while carrying their duty inside the building. So it's important to have a good mechanical ventilation system because ventilation system is used to provide the good indoor air quality and provide the fresh air to the building. So increase of the level of indoor air pollutants, variable particulate matter, indoor CO2, and carbon monoxide concentration, like thermal comfort, relative humidity, all of this will affect the comfortable of the occupants. In this study, air conditioning ventilation is essential in a building because it is influencing human productivity and the health. Failure of ventilation system cause insufficient airflow will lead to the IAQ problem. In SARS 2020 review, the bad indoor air quality causes sick building syndrome will affect the productivity of staff in office building and cause the economic consequences. Inadequate ventilation will increase the carbon dioxide concentration and lead to the bad IAQ. Therefore, a lot of commercial buildings are concerned about the indoor air quality of building. So it's interesting to evaluate the indoor air quality at a small commercial office building and improve it by the proposed method. My objective is to propose a system reconfiguration for improvement of indoor air quality for a small commercial office space and to evaluate the effect of airflow to carbon dioxide concentration, air temperature, and relative humidity, and to compare between several HVAC system configuration for optimizing acceptable indoor air quality for a small commercial office. In literature review, I go through some literature review. So for indoor air quality, United States Environment Protection Agency state the indoor air quality refer to the air quality within and around the building and structures, especially as it related to the health and comfort of building occupants. And IQ is defined as a concern with the temperature, cleanliness, oxygen concentration, moisture content, and the movement of air. When we talk about the indoor air quality, we need to refer to the SAN standard. So the standard, which is ISO 7730, SRES standard 62.1, SRES standard 55, and the DOS 2010. So in my study, I will refer to the SRES standard, which is 62.1 and 55. For carbon dioxide, less than 1000 in office. However, for temperature is 23.3 until 26.7. The relative humidity is 50 until 60. Air velocity is less than 0.15. For the indoor air quality measurement, I will use the indoor air quality survey and physical measurement. So, however, based on the study, the Prior and the Kanja 2016, they use the X-ray thermoscale and 7-point humidity and movement sensation to evaluate their parameters. For Abdul Rahman, using the 5-point Likert scale. To improve the indoor air quality study, they have a two study I go through, which is Zendel 2020 stated the decentralized vacuum ventilation system can improve the indoor air quality by reduce the carbon dioxide concentration by adjusting the supply and exhaust system. However, for Alatros and Kratik 2016 stated that the natural ventilation reduce energy consumption and improve the air quality by applying opening window. In modeling and simulation, I choose for HAP, Hawali analysis program, which is to calculate the design cooling and heating load for space and zone and coil, and to determine the required airflow, rate, and for space, zone, and system, and also to determine the CO2 level. However, for content, it's used to determine the airflow pressure, such as room-to-room airflow in building, and the contaminant concentration as well. And we go to methodology. For process one, we need to do data collection. Data collection process of indoor air quality based on the survey and physical measurement was conducted in the office space of building. The result was compared to the SRES standard 55 and 62.1. And survey was evaluated through a 5-point Likert scale. Process two is acquisition of building condition. The design of parameter of physical office were developed using the HAP software with the existing component configuration of the HVAC system. And the survey regarding the indoor air quality assessment was discussed. However, the process 3 is a comparison of existing building condition. The comparison between the measured data and the design data determine the indoor air quality problem. For process 4, proposed hardware reconfiguration system, the proposed methods were simulated in the problematic office room to improve the indoor air quality. And proposed methods are natural ventilation configuration and the decentralized ventilation configuration. Natural ventilation configuration use a constant airflow with open window. However, the decentralized ventilation configuration use a constant supply and exhaust airflow. And HAB and content simulation are used to simulate the indoor air quality parameter in an occupied small commercial building, which are operating temperature, relative humidity, airflow, and carbon dioxide. In process 5 is a result analysis. Comparison between two HVAC system configuration in each room were discussed to optimize the acceptable indoor air quality for small commercial office. Analyze the effect of airflow to carbon dioxide concentration, air temperature, and relative humidity. Yeah. And if the indoor air quality is achieved, the modeling was ended. In result and discussion part, the questionnaire was distributed to all occupants of small commercial office building, and all the distributed questionnaire were successfully retrieved. So first, as you can see this figure, most of the occupants is male, which is 63.3%, and 16.7% was female. Second is a distribution of year of service at the office, and third is the number of hours spent per day at your main station. So as we can see, for the first one is a percentage of the occupants vs a year of the service, which means that there's 40% of the occupants are served in this office around 2 to 5 years. However, they have 13% that are served in this office more than 20 years. They have 67% of the occupants spend their time in the office around 6 to 8 hours. These two factors significantly will affect the accuracy of the survey. Fourth is thought about the comfort of the occupant in the office. So here I'm listing down for several factors that will cause the uncomfortable to the occupants. The first one is the bed drop. The second is the room temperature too high, sweating and uncomfortable, up and down room temperature too low and cold and dry, stuffy air, dry air, unpleasant odor, dust and dirty. Yep. So as we can see, for the red color one and the green color one is every week and sometime that happen. I mean, this factor happen. So we know that the every week factors that will happen will be the drop and the room temperature up and down and the stuffy air, and also they feel the actually the environment is dust and dirty. Yeah. And some of the occupants saying that this sometimes happen. So this result indicated the office environment actually having a problem and causing a discomfort to the occupant. Analysis of symptoms at the workplace based on the past experience. So from here, we can see that they have a different feeling or different experience that occupants feel before, which is the headache, tiredness, fatigue, drowsiness, dizziness, difficult breathing, and cold, stuffy noise, and dry throat. So we can see that the first one is every yes often that happen every day. As we can see, there is 7% of the occupant that feel the stuffy noise that happen every day in the color of orange. For the brown color, it's happen in some time, means 2 to 3 times per week. As we can see, they happen at tiredness, dizziness, fatigue, stuffy noise. Yeah, in a different percent of occupants saying that. 33% of the occupants saying that they feel the dizziness. Another sometimes is 2 to 3 times per month. So the headache is frequently, is the most highest occupant setting saying that, which is 47 occupants saying that they feel their headaches 2 to 3 times per month. Based on this symptom analysis, we truly believe that this office environment having an indoor air quality problem. Since our office has a 5 room, which is a lobby, service office, total line office, manager office, and sales office, so we need to figure out which office is the most problematic office. Yep. So as you can see, they have a 2 highest percentage, which is 2 color, is a green color and a white color, and there is a service office and a sales office. 33% of the service office of the occupants staying in the service office feel the tiredness and also the drowsiness, dizziness in different percentage. Yep. And for the sales office, Also, they have a 20% in their fear of headaches, drowsiness, and cold. Yeah. So these two office will be the problematic office, and my study will be focused in these two office. So now I discuss about the comparison between the design data and the measure data in a different parameter. So first, we discuss about the relative humidity. So as we can see, they have a 5 room and they have a difference. So based on this, we know that the service office and especially the service office and the sales office have a highest relative humidity if compared to the design data. Yeah. So in the express standard, the relative humidity actually is in the office is below 60%. So in here we know that the relative humidity in the office is not acceptable. So in terms of temperature, as we can see, service office and sales office have the highest indoor temperature. Service office has 28.8 Celsius and sales office is 27.5 Celsius. And in express standard, they indicate that the acceptable range for the indoor temperature in office is 23.2 until 26.7. So it's actually the measure data actually over than the standard of the X-ray. So the temperature is definitely cannot accept. Internal airflow, as we can see, all the airflow is enough. So in here, the airflow should be no problems because they having an airflow in the office. Last, we can see for this carbon dioxide concentration, the measure data of the service and the sales office are higher than the design data, around 322 ppm, which is 32%, and the sales office is 264 ppm with 28.3%. Yep, the higher concentration of CO2 will cause the stuffy air and headaches to occupant. And the express standard office CO2 concentration must lower than the 1000 ppm. We can see that for this average result actually is quite nearest to the 1000 ppm. So it will be the problems to the occupant. In this study, I will using the content software to simulate my result. So they need to do the validation to check the accuracy of the content. Here in this figure showing the validation of content result against the measure data and design data. And the different content result and the design data was smaller. For as you can see in the red color and the green color one, which are only 1.6%. However, the difference between the content result and the design data indicate the degradation of the building and the mechanical system. And this building was used in the past of 20 years ago. After that, I'm going to propose the Herschel reconfiguration for IAQ improvement, which is natural ventilation with opening window and decentralized ventilation with supply and exhaust. So these two diagram is the proposed natural ventilation configuration, which is the opening window, and another one is a decentralized ventilation configuration with supply and exhaust fans. So in the simulation, I refer to the literature and put these content parameters to my content software. I have a door, window, entrance door, emulate wall, and a ceiling. For the simulation in space layout for content, this is the layout that you can see through this picture. And here is a simulation result on the natural ventilation and decentralized ventilation for service office and sales office. So for natural ventilation, as you can see, I circled that. I represent that as a opening window that have flow from ambient into the office. Yeah, just as the sales office as well. Same. And the decentralized ventilation also they have airflow into the office and outgoing to the ambient, which is a supply and exhaust. So for the result, for service office in terms of temperature, as you can see, the red color one is a measure, the black color one is a natural ventilation, and the orange color one is a decentralized ventilation. So natural ventilation was introduced because it can direct cool the building occupants by directly cool the building interior by replacing and dilute the warm indoor air with cooler outdoor air when the conditions are favorable. And natural ventilation decreases 3% in temperature compared to the design temperature. So this, however, the decentralized ventilation helped to decrease the indoor temperature to convert the temperature. The different temperature between the physical measurement and the simulated temperature was 2.8 Celsius, which helped to improve the temperature comfort in 10.6% as compared to the measured temperature. In terms of relative humidity, the natural air is allowed to flow into the building. The relative humidity will decrease around 7.3%. When fresh air enters the building, air change rate increase, stuffy air reduce, and the relative humidity will reduce as well. In decentralized ventilation configuration, the exhaust fan help to increase and circulate the airflow inside the building and reduce the humidity, which help reduce 18.9% as compared measured relative humidity. However, in carbon dioxide concentration, you can see from this figure, the natural ventilation configuration, which is the black color one, is the opening window. With the opening window with constant airflow was set in the simulation to bring the fresh air inside the building, and it reduced around 31.8% of the carbon dioxide concentration as compared to the measured data. However, for the decentralized configuration, the exhaust fan helped to reduce the carbon dioxide concentration effectively, which reduced around 37% to 78 ppm of the CO2 as compared to the measured data. For sales office, in terms of temperature, the temperature of the decentralized ventilation configuration was decreased around 6.4% compared to the measured temperature. Especially in the higher temperature period, it reduced to 2.8 degrees Celsius. And while the temperature in natural ventilation configuration also decreased around 2% compared to the measured temperature. However, decentralized ventilation configuration provide a better ventilation, which is supply fresh air and using an exhaust fan to discharge the stuffy air. In terms of relative humidity, the relative humidity for natural ventilation configuration was lower around 10% compared to the measured relative humidity, while relative humidity of the decentralized ventilation configuration reduced around 23.6% compared to the measured relative humidity. Increase the air change rate means to supply enough fresh air and exhaust hot air, then it can reduce the relative humidity. However, for the carbon dioxide concentration, natural ventilation with constant airflow allowed the fresh air enter the office and reduce 43% of the carbon dioxide concentration. The average of the CO2 concentration in decentralized ventilation configuration is 405 ppm, which reduced 56% compared to the measured CO2 concentration. So, in conclusion and recommendation, decentralized ventilation configuration was the most suitable in service office and sales office. As we can see, it reduced 43% of CO2 concentration in service office, while reduced 56% of CO2 concentration in sales office. The fresh air flow into the building is necessary in all buildings which provide enough air change rate, and the indoor air quality can be improved when fresh air can circulate inside the building. And last, in the view of cost, decentralized ventilation is more reliable, which there is no huge installation cost compared to the natural ventilation. And for recommendation, more parameters such as carbon monoxide, volatile organic compound, and formaldehyde is better to analyze the indoor air quality, and it can include all these parameters in future study. And also, comparison between the content and the CFD software can be discussed as well to have a more detailed analysis, such as the airflow pattern and the position of the opening window, and also the position of the supply and exhaust fan. And this is my reference that I'm using that I refer to. And this is my presentation. Thank you.